Watching at home, there is no Dom. We're getting started. Who can tell me about how to find the distance between 2 points? Pythagorean theorem? Yes, you could do that. But if you're actually given coordinates, what's the other formula that we've given you for that? Well, you've learned at some point in your life. Give you a hint. There's your hint. Yes, sir. Very good. Very good. The distance formula, which is actually the same exact thing as the Pythagorean theorem. It's just instead of putting in side lengths, you have to subtract for your side length. Right. Distance formula. So let's just pick one and go. How about number 11? Number 11. x2 minus x1. 3.5 minus negative 0.5 squared plus 8.2 minus 6.2 squared. So that's going to be 4 squared, 2 squared, and the answer is radical 20. Distance formula. Questions about any step that I took right there? Alright, then let's just keep going. Anybody want to see another one on this page? 15 because the radicals, right? Okay, I'm just going to make a little partition right here. And do it over here. Much smaller though. Radical x. That's not enough room. I'll do it down here. Radical x2. Not that it really matters which one you do first. Minus x1. Because you're squaring it, so it's not going to matter. Plus y2. Which one did I do first time? Second. Plus y1 minus y1. So, negative radical 3 minus 3 radical 3 is how many radical 3's? Minus 1 minus 3? 4. Minus 4 radical 3, which we're going to square in just a second, plus 4 radical 5 minus 1 radical 5, 3 radical 5, also squaring that guy. Now, when you square radicals, remember, you have to square both numbers. Square root of 3 squared is just 3. Square and square root cancel. What's negative 4 squared? 16. So that's 16 times 3. This is going to be 5 times what? 9. 9, 5. So that's 48 plus 45. So that distance is the square root of 93. Which you can leave like that. Actually, technically, this is 2 radical 5, isn't it? Didn't reduce my radical. That's the same as the square root of 4 times the square root of 5. So it's 2 radical. No, I just realized I forgot to simplify that one in my rush. Radical 93 does not simplify what? I don't care, but on your test it's going to be 2 radical 5. I mean, if you have one like that, so you would just need to know. That's where that's coming from. Although you will have number crunching calculators, so you could always punch in square root of 20 equals 2 radical 5 equals, see if they're the same. Okay. Questions on this slide. Distance formula. Great. Moving on. I'm just trying to get this whole thing in before I have to leave. I have no idea what time they're coming for. Midpoint formula. Who remembers that formula? Ouch. It's just the average of the x's and the average of the y's give you the midpoint of a segment. The 2x values over 2 and the 2y values over 2. So once again, let's just try to jump straight into one of the harder ones. How about 25? So we need to find, first off, the average of the x values. So what's negative 7 halves minus negative, plus negative 5 halves. We'll divide it by 2 in a second. I'll go ahead and set it up. But first we need to do the top. Negative 7 plus negative 5 is what? Negative 12. Negative 12 over... What's negative 12 over 2? Negative 6. What's negative 6 over 2? Negative 3. So that's our x-coordinate. Then we just need to do the same exact thing for the y values, which I haven't left myself a lot of space here. I don't know why I'm writing so big today. Our y values. Let's see, which one did I go with first? This first one? All right. Y minus y. Well, we'll just do all that first, and then I'll put the whole thing over 2. 3 minus 11. Negative 8. I didn't write the over 2 here the first time. I just had space. That's going to be what right here? Negative 4, which is negative 2. So that is our midpoint. Now that's the hardest one I could fathom you having, because there's fractions inside fractions. Most of them, as you can see, are just whole numbers. And this is a much easier formula. But I thought we would just start off with a bang. You want to do a radical problem? 30, all right, we'll do. Midpoint for number 30. I beg your pardon? Right here? Negative 7 plus negative 5. Yeah, that's where that came from. You need me to leave this up here for a second? Sure. Well, we're going to be doing number 30 next, so if you want to go ahead and get ahead of me and start doing the first few steps on that one, that would be fantastic. Just leave it as a fraction. Good question. Josh said, what if it's an odd number and you can't divide by 2? Leave it as a fraction. And even if you have something like this, I can't imagine you getting something that's ugly. Well, let's say you had something like this, okay? Really ugly. Isn't that the same as negative 7 over 2 divided by 3 over 1? Flip and multiply, and that's how you would reduce that. So it would be negative 7 over 2 times 1 over 3, so negative 7/6. I can't imagine you having something that ugly. But if you did, just remember, flip and multiply to make the bottom one into a fraction too. Good question. And our answer was up here at the top if you're writing this down. Here was our actual answer. Anybody need me to leave this up here for a second? All right, number 30. All right, x2 plus x1. Now, radical 50 plus radical 2 over 2. Your test is going to leave it in radicals. It's not going to put it in decimals. Is there any way that we can break down radical 50 so that it's something times radical 2? Yeah, that's the same as square root of 25 times square root of 2. This is just this piece, which is the same as 5 radical 2. So if we add that to radical 2, 5 plus 1 is 6 radical 2 over 2. And how does this reduce? Three radical 2. 6 and 2 reduce to 3 radical 2. The y values are going to be pretty darn simple. Negative 6 plus 6 over 2, what's this going to be? 0. So the midpoint of that guy is 3 radical 2, 0. Questions on that one? That's midpoint and distance. I'll tell you right now, there are one of each of those on your test. So even though we're kind of doing it here real quick, because they're review, that's why we're doing it real quick, but there will be at least one of each of those on your test. So make sure you know what we're doing here. And when I leave, you guys will have tons of time to work in groups and discuss that some more. And tomorrow on review days, those are good days to ask questions on homework and stuff too, because the review won't take us the whole block. I don't think. Okay. Already did that. Write the standard form of the equation of the circle. Equations for circles. Who remembers the equation for a circle? Anybody remember what that was? It's actually very, very similar to the Pythagorean theorem, only it starts out x squared, y squared, r squared. But who remembers how the center worked into this formula? Give you a hint. The center was of form HK. Remember? It was this. Oh, but now the squared goes on the outside. X minus h squared plus y minus k squared equals the radius of our circle squared. That is the standard form of the equation for a circle. Now the center will always be a form HK, you just plug it in. So like 35 right here. 35. X minus, what's my x coordinate? -1, which you could go ahead and switch to +1 to save time. I mean by making it +1. Plus y minus, what's my y coordinate? 4. And what's my radius squared? 4. And that's it. That's all there is to making the equation of a circle. Plug it in the center, plug it in the radius, and squaring it. Let's look at number 37. By the way, remember, if you ever have like something -0, you can leave it in there as -0 if it makes you feel better. But if you had like x minus 0 squared, I also would not begrudge you if you just made that x squared, because -0 is not going to do anything. But I don't really care either way. Okay, number 37. X minus -3, which is the same as +3, squared. Y minus -1, which is +1, squared. And what's this radius squared? 3. Very good. Square root of 3 squared is just 3. While people are writing that down, are there any questions about how we're getting these answers? Big thing is to have the formulas in your notes. If you have the formulas in your notes, then this whole section is just plugging stuff into formulas. No? Okay. Give the center and radius of the circle described by the equation. So here they're giving the equation. They want you to extract the center and the radius. What 41? What's being subtracted from x? Nothing. What's being subtracted from y? Nothing. There's your center. What's the square root of this? And there's your radius. Let's look at a different one. How about 45? What's being subtracted from the x? That's right. Remember, it's being subtracted from, so that's -3. What about this one? 2. And what's my radius? You guys seem to have a handle on this. I know we're going at warp speed, and I appreciate you guys focusing so much. I really wanted to just get this done, because I will not be back in this class. Questions on that slide? Then you need to leave this up there for a second? Alright. Now, I've been coming around while some of you all are working during the day, and I've been seeing how detailed your notes are, and that's fantastic. I know I've seen a lot of you writing down the directions. What you may want to do to save time while we're doing this is, like, on all the directions that we do, it usually has problem numbers. So maybe before those problems, rather than write down all the directions, you can write like C, 41 through 52. That way when we're doing the lesson later, you can go back and see what the directions were for that problem. Just a suggestion. Alrighty, here we go. Graphing circles. Well, what's the center of that circle? -3, 2. And the radius is, so just go out 2 in every direction. Connect your dots. Doesn't have to be perfect, obviously. And there you go. Questions about where any of that came from? Pull out your center. Do you have a question? I was just going to say, you pull out your center, pull out your radius, and then apply that radius in each direction from your center and connect the dots. Did you have a question? Remember, it's the square root of that number. Yeah. Good question. Remember, this is r squared, not r. So you have to take the square root of it every time. Good question. Any other questions? No. Okay. 53 to 64, complete the square. Rewrite the equation. Okay, we can do this. Alright. Completing the square. I may just want to come back and hit on this later all by itself. It's kind of a standalone thing. Let me tell you what's going to happen, by the way, this semester. We're going to finish everything I want to get covered in this book with like a month to spare, and then we're going to go back and hit on the things that we kind of went over quickly or just skipped. That's the way it's going to break down. The way this, we're going to finish everything I want to get done with like a month to spare, and we're going to come back and hit on some of these things I'm going to jump over. So I'm going to go ahead and actually skip over this, and because it's not going to be on your first test, and I don't want to confuse just this last section with something complicated. So we'll come back to that. Graph both of these equations. Yes, this we can do. Then show where they intersect, which you can either eyeball or solve the system of equations. Actually, in this section, you'll probably just eyeball from your graphs. That's the point. We're going to be solving systems of equations a little later. So, 67, graphing. What's the center of my first equation? What's my radius? 4. Now my graph is not going to be very good. The better your graph, the easier this is going to be to do. Yeah. Whatever. Alright. What is this equation? What's a more graphable version of that equation? What would make this easier? Hint, it's a line. If there's no squares, it's just a line. So what would make this thing easier to graph? Yes, solve for y. Now, y-intercept of -4, well, that makes it really easy where this thing's going to intersect. Slope of what? +1, up 1 over 1, up 1 over 1, up 1. Hey, that's going to make it also easy where this thing intersects. Draw a line through those points. Oh, this is not going to be good. That's not bad. And they intersect. And I'm guessing all of these are going to be nice full points. They're not going to have like a tweener here you have to eyeball. So those things intersect at 0, -4, and 4, 0 looks like. Who can tell me how to check those points and see if those are... Yeah, if you plug them both into both equations, they should both turn out with true statements. Like if you plug this one into the top one, you get 16 equals 16. That's true. Plug it into the bottom one, you get 4 equals 4. That's true, which means this point works in both equations. And so with the second one. That's not required, But it's a good way to check and see if you're right. Just plug the points into the equations and see if you get true or false statements. So graph both of them. This one's the same thing, except for what's the center and radius of my circle here? 2, -3, and my radius is 2. Let's graph the points and go. Questions? What were those numbers I skipped? 53 through 64? Okay. I cut this thing down to every other even, which is every 6 problems, so 2, 8, 14, so that we could throw a few review problems in here too, so it'll make tomorrow's review a little bit more familiar. Let me tweak this. 2, 8, 14, 20, 26, 32, 38, 50. 66, 68. Dang it, what was I going through in the first place? Here we go. Yeah, that's right. Right.